Okay, Chloe, we did not record yesterday, 5th period, so I'm recording right now with Liv, and we are doing 12.4, and this is permutations and combinations. So in your calculator, you have a button that looks like, it's like NPR, and you have a button that's NCR, okay? And does she have the same calculator as you? No, she doesn't. It might be if you don't have it on the main screen. Sometimes you, I think, Chloe, your calculator maybe does it where,
Here's what I found.
it does it where it's on the main screen and you just have to hit the shift button. But Olivia's is under a button that says PRB for probability. So you go here under PRB and there's where they are. Okay, so here's the deal between NPR and NCR, just in a nutshell. I'm going to skip all of this other jazz over here and I'm going to show you what NPR and NCR are. Okay, let's say we had, so yesterday in the 5th period class we had 9 students. Okay, and I want to choose 3 students. And the first thing I'm going to do is I'm going to choose 3 students and I'm going to have them be a part of a committee. So they're going to be on the recycling committee where they go around and they recycle the paper in the school, whatever, okay? And when I go about choosing those students, like the first person I chose was Remington, capital letter, Remington. Then I chose Avalee, and then I chose, I don't remember who it was, Megan, okay? So out of those 9 students, those are the ones that I chose. I chose Remington, I chose Avalee, and I chose Megan, okay? If instead I would choose Megan first, then Remington, and then Avalee, does it matter that I announce their names in a different order?
No.
Are they still going to serve the same purpose on that committee?
Yes.
Yes. So when that is the case, when order doesn't matter, when there's no order, when we don't care about order, we're doing a combination. Okay, so when we would calculate that, we're trying to figure out how many groups of 3 students out of 9 I could choose, right? Because Remington, Avalee, and Megan, that's only one combination. How many total possible combinations are there? Like how many groups could I make if I have 9 students? Like I could swap out Megan and put Delaney instead, right? Okay, that's a different group. So how many different groups could I have? What we do is, since the order doesn't matter, the way that I'm choosing them, I would do 9 for my N, and I'm choosing 3. So it would be 9C3, and you just type that into your calculator. So you type in 9 first, and then you'll go to that NCR button, and then you'll type in 3, and you'll hit enter.
So what do I do?
Okay? Oh, did you type in 9?
No.
No. Go back to the main screen. Clear. Okay, well, I'm going to type in 9 first. 9. Okay, and then I'm going to go to the PRB button, and I'm going to go over to C, and I'm going to hit enter. So it's going to put it on the main screen, and then I do 3. And I hit enter, and there are 84 total different groups that I could create by grouping 3 students out of 9 students. That's a lot, right? Like swapping kids out and doing whatever, okay? And that's even if order doesn't matter. Now, if instead I had those same 9 students and I was choosing 3 students, but I was choosing them to be president, vice president, and secretary of their class, right? And let's say I chose Remington first, that means he was president. Avalee second, that means she's vice president. And Megan third, that means she's secretary, okay? Is that going to be different than if I choose Megan first as president, Remington second as vice president, and Avalee third as secretary? Yes, because they have different jobs. They're not on the same committee. They're not all doing the same job. They have different jobs. So yes, order does matter. And when order matters, we use the P instead, and that's for a permutation, not a combination. So permutation starts with P, combination is the C part, okay? So there is that. Now, the way that I can remember that, oh, by the way, we will do 9C3, or 9P3, to figure out how many different ways I cannot do this today. 9P3 to figure out how many different ways of groups I can do.
504.
504, that's a lot more different groups, okay? And the reason why it's more is that even with those 3 same people, I could rearrange them and that's considered to be a different group, right? Like this is a different combination than this one. Whereas in a committee, those would be the same, right? Okay, so I'm gonna have a lot less combinations than I am permutations, right? Okay, now here's how you remember. Committee, starts with a C, and in a committee, they're doing the same job. Combination starts with a C, right? But in a P for permutation, the order matters, and so does president, vice president, secretary. So if you're doing a ranking, president, vice president, secretary, P, you're going to use P. If you're doing a committee where order doesn't matter, you're going to use C. That's how I remember that. P and P, C and C. Good? Let's go to an example. Example 1. Taisha and Liam are signed up for an open mic night with 32 available slots. Okay, so 32 is going to be a variable, and that is going to be your N, right? That's the total number that I have. What is the probability that Taisha will perform first and Liam will perform second? Okay, so let's first decide, what's the R value going to be? Like, R is the number that we're
32.
choosing. 32 is the total. How many people are we choosing out of the 32? 2. So R is 2. So now we just have to decide if we're going to do 32P2 or are we going to do 32C2. That's all we have to decide. Okay, Taisha will perform first and Liam will perform second. Okay, does order matter? Yes, first and second are going to be different, so I'm going to use P instead. Okay, and 32P2 is going to be a huge number. Is 992. Now, the only difference is they say, what is the probability that this person's first and this person's second, right? This is how many combinations there are. But there is only one combination out of the 992 that has Taisha's, whatever her name is, as first and Liam as second. So that's how we make that into a probability. 1 out of 992. Okay? Good. Example 2. For a final project, Rami selects 12 family photographs that will randomly play in a slideshow. Okay, so we've got 12 photographs total. Whoop, and now they're going to give us the photographs for us. They say the slideshow will not repeat until all 12 photographs have been shown. That's not trying to confuse you. That's just making the problem easier. So don't ignore that. 3 photos are of the entire family. So 3 photos of the fam. 2 photos are of the brother. 3 photos are of just him, and 4 photos are of the sister. Okay, so that's the breakdown of photos. Those add up to be 12. Okay, what is the probability that the first 4 pictures in the slideshow will be of Rami's sister? The first 4 pictures are going to be of Rami's sister. Does it matter the order that those 4 pictures appear in? No, we just care that they're the first 4, right? Okay, so we have to figure out what N is, and we have to figure out what R is. That's where I start from if I'm ever confused. I just need to know N and R, and I need to know whether it's a P or a C. That's all I have to do.
12.
Okay? So N is 12. Yep. R is how many? 4. And did we say it mattered the order that they went in, or it didn't matter the order? No. So which one do you do? P or C? C. So in this case, we're going to do 12C4. It does not matter the order that they're going in.
495.
495, okay? And it says, what is the probability that the first 4 pictures are hers? 1 out of 495, yeah. Okay. All right, good. All right. Let's go to the next one right here. Okay. All right, one more formula that you need to know for example 3. And I'm going to do it over here. O-L-I-V-I-A. Yes, we're going to do it. Olivia, O-L-I-V-I-A. Olivia, you have letters in your name that repeat. The I does, right? Okay. So here's the deal. I'm going to take and I'm going to chop up the letters of your name, and I'm going to throw them into a hat. I'm going to pull them out randomly and see if we can spell the word Olivia, right? Like, chances of that happening are probably slim to none, because I'm probably going to pull out like an A first or something like that, right? And that would be not right, okay? But just hear me out. We're going to chop those letters up, and we're going to throw them into a hat, and we're going to spell Olivia. So if I pull the O out first, I'm on a good start. If I pull the L out second, oh man, it's looking good. If I pull this I out third, the V out fourth, this guy out fifth, and this guy out sixth, he will spell the word Olivia exactly. That would be awesome, okay? But let's say instead I pull the O out first, right? The L out second. Let's say I pull this I out third, this V out fourth, this I out fifth, and this A out 6, will I still spell Olivia? If I switch these two I's around,
Oh, yeah.
will it still spell Olivia? Yeah, but technically that's a different combination, technically, but it will still spell the word Olivia. And it has to do with the fact that you have two different letters. So if we're talking about the number of combinations, like that I could spell, like how many words, or I guess they would not be words, right? How many things could I spell out with the letters of your name? Like I could spell Liiavo, right? That would be one combination. Or I could do Ilavoi, right? Like that would be another non-word. How many of those do I have that I can make with the letters of your name? Now here's the deal. The formula for this, because it has repeats, the formula for this is n factorial over r1 factorial times r2 factorial ... and it just depends on the bottom number, how many letters you have repeating. Okay, so we'll get to that.
What?
R1, it's like a R1 subscript factorial times R2 factorial, etc. Okay, do you know what a factorial is?
No.
Like if I say 3 factorial, that means 3 times 2 times 1. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, in your calculator, you have a factorial button. It's like that exclamation point, and it's in the same spot as your NPR and NCR. So go to your PRB, and it's just over that farther. Yep, that's it. Okay, so how do we figure this out? How many of these little non-words are there, words or non-words, that we can spell with the words Olivia, with the letters Olivia? Well, in this case, what would N be, do you think?
5.
5?
6.
6. There are 6 letters in your name. 1, 2, 3, 4, 5, 6. You were probably thinking 5 because you're deleting the I out. I think, maybe. Okay, so 6. So we would have 6 factorial over. You only have one letter that repeats. Okay, so we're only going to have one number on the bottom here, but how many times does that I repeat? Twice. So we do 2 factorial in the bottom. So you're going to take 6 factorial and you're going to divide by
What about the
2
one?
factorial. What?
What about the rest?
What? So this guy right here is if you have multiple letters repeating. So if you had another letter that repeated twice, we would do another 2 factorial, etc. on the bottom, but we don't. So you're just going to do 6 factorial divided by 2 factorial. So how many different words and such can we make with the letters of your name?
360.
360. Perfect. Okay. Now, what's the chances or what's the probability of me spelling Olivia exactly?
1.
1. There's only one combination that's going to spell Olivia exactly out of 360. Because originally there was 2 different combinations that would spell Olivia exactly, right? If I switched those I's around. But now we've deleted out the number of repeats that it has. So now I have 1 out of 360 instead. Okay? All right, let's do this problem. Example 3. We're going to skip example 4. Example 3. This one says one game show has contests, has contestants arrange 5 numbers to build their guesses at the price of a prize. Have you seen this before? Mm-hmm. No? So they'll tell them what numbers are involved in making the price. So they could have made this price like $25,852, right? Or maybe they have a car there and they think it's worth $25,000. So they arrange the numbers in that order. Maybe they think the car is worth $85,522, right? So they could arrange it that way. So it's like a guessing game, and you have to like figure out what price is based on what numbers they give you. So it's kind of fun. Anyway, whatever. All right, we want to first figure out how many different ways we can arrange those numbers, but we have numbers that repeat. They are 2 and 5, right? So we have n factorial over r1 factorial times r2 factorial, etc., right? Okay, so what is n in this case? 5 different numbers, right? 1, 2, 3, 4, 5. So 5 different numbers, so 5 factorial. Now, the first number that repeats is 2. But how many times does it repeat? Twice. So we have 2 factorial. Okay? Times, the next number that repeats is 5. So what do we put down here?
2.
We still put 2 factorial because that's it's the number of times it repeats. It's not the actual number, right? Now, when you do this, when you type this in, you might need to put a parenthesis before and after your 2 factorials because it will calculate it the wrong way.
$120.
Okay, you gotta put I'm gonna get rid of this. You got to delete this guy, and I'm gonna do times. So it's gonna do this operation first. 30. So there's 30 different ways of arranging those numbers. Yep. So gotta put parenthesis, times, parenthesis, so that way it does this calculation first, and then there's that. So what is the probability that she gets this combination exactly? 1 out of 30. Now that we've divided out the repeats, there's one combination out of 30 that gives me that. Okay? All right, we will skip number 4. Let's skip 4. And we will go to homework. 5 problems. 2, 4, 5, 10, 12. So 3 different things that we have going on. We have combination, permutation, and repetition. So you either decide, is it a combination, is it a permutation, or are letters repeating? That's it. And it's one of those 3 different things that could be happening. That is all. Okay, 2, 4, 5, 10, 12. Beautiful.